This video will be about the multiplication properties of exponents. So when you're multiplying two things together and they have exponents involved, we can figure out a shortcut way. We can always do it what I call the long way, which is to write out what we know exponents mean. X squared really means multiply x times x, and x to the fifth means multiply x times itself 5 times. 2, 3, 4, 5. So if we were to count all of them up, we have 1, 2, 3, 4, 5, 6, 7 of them, which would be x to the 7th. Well, we want a way where we can just go from the start here to the finish here. Well, if we look at the 2 and the 5, we know the only way to get a 7 using a 2 and a 5 is to add them together. So when you're multiplying terms together that have the same base, notice these both have the letter x, you can just add the exponents together to get the final answer. So what they're going to do is they're going to make it more complicated. It seems super simple right now, but they're going to combine a lot of things together. So let's say we have 2a to the 5th b to the negative 3rd times 5ab to the 2nd. So first of all, every variable needs an exponent. The first a has its 5, b has a negative 3. The second a doesn't have anything written in its exponent spot. When that happens, we know that there is an invisible 1 in that exponent spot. So we need to write that in. And then b already has an exponent. So when you go and do a problem like this and there's a lot going on, you group the things together that can actually work together. So like the 2 and the 5, those are just both regular numbers. And you're multiplying, so we would do 2 times 5 is 10. The a to the 5th and a to the 1st, again, we're multiplying and we have the same base, both the letter a, so we know we actually add those together. 5 plus 1 is 6. The b's, we have a negative 3 and a positive 2. When we do negative 3 plus 2, that will come out as a negative 1. So here we run into a problem. When you're working with exponents, you never want a negative exponent left as part of your problem. So we don't like that this b has a negative 1 on it. What we've got to do when that happens is, if it's not already a fraction, which it is not, we're going to put a fraction bar underneath everything, and the piece that has the negative exponent is going to move levels. Since it is on the top, we're going to move it to the bottom level, and since it's a negative exponent, when you do that movement, it'll make it become a positive exponent. So this b to the negative 1 will move to the bottom, which will give us 10a6 b to the 1st. Now what we can do, since b is positive 1, we don't have to write that in. Just like we had a with an invisible 1 here, we can make the 1 invisible on the b. So that would be our final answer for this particular problem. So let's do another example. Okay, so looking at this one, 3 doesn't have another big number in front to work with, so it would just stay the same. X to the negative 5th times x to the positive 5. Well, if we do negative 5 plus 5, we get 0. And then b to the 8 times b squared, 8 plus 2 would give us 10. So here is one other thing that can happen. When you get an exponent of 0, anything raised to 0 is always 1, every time. So this is really 3 times 1 times b to the 10th, which would just be 3b to the 10th. So the second part of this section talks about scientific notation. When you have a really, really big or really, really small number. So let's say we have 2,500,000,000,000. Mathematicians didn't want to have to write something that big, and scientists, so they came up with a way to write it a little bit smaller. They always put after the first digit a decimal, so 2.5, and then you're going to get rid of any zeros by writing it in what's called scientific notation. So the decimal, if we hadn't written one in, would originally start on the very right-hand side. All we have to do is count how many spaces it takes to get it after that first digit. So that is 9 spaces. And we can write this as 2.5 times 10 to the 9th. So what we're going to want to do with our scientific notation is we want to be able to multiply two numbers together. So let's say we have 2.5 times 10 to the 9th times 3 times 10 to the 5th. So just like our multiplication we were doing before, we kind of group it together into things that we could actually work with. 2.5 times 3 will give us 7.5. And then if we do 10 to the 9th times 10 to the 5th, they have the same base of 10, so all we do is add the exponents. 9 plus 5 is 14. So this answer would be 7.5 times 10 to the 14th. So let me show you another example of this because there will be some trickier type of questions. So we have 5 times 10 to the negative 8th and 7 times 10 to the 5th. So again, we multiply the numbers in front together. 5 times 7 is 35. And we add the exponents. Negative 8 plus 5 is negative 3. Now we actually have a problem here because we know scientific notation is supposed to have a decimal right after that very first digit. So if there was not a decimal written in, we'd have one after the 5, and we have to move it over 1 to make it 3.5. Well, that's going to change our exponent here. If we move that 1, that would be times 10 to the 1st, because we know we had one decimal place it moved, times 10 to the negative 3. And we have to combine these bases again. 1 plus negative 3 would give us negative 2. So our basic rule for this section is that when you have two bases that match, the 10 and the 10 here, you add the exponents, 1 plus negative 3. But when you had a whole bunch going on, you had to group like terms and combine those together. And if there are numbers in front, you still just multiply them together. You don't have to worry about any of the weird new exponent rules. So that concludes our discussion for multiplying with exponent properties.